Hey Astro fans! Yesterday we saw the release of the first set of data from the Gaia mission. It was so exciting! What do you mean you don't know what I'm talking about? The Gaia mission is a satellite that was launched in 2013. Its primary goal is to map the stars in our galaxy, something called astrometry. And yesterday it revealed to us the positions of over 1 billion stars. Yeah, a billion. That's about 1% of the actual total population of stars in our Milky Way galaxy. And the precision is even more impressive. If you take a single angle on the sky, 1 degree, and you divide it by 60, and you divide it by 60 again, you have something called an arcsecond, which is already pretty tiny. But if you then divide that by a further 10,000, that is how precise the measurements are on Gaia. So the analogy that people were using in the press release was, if you imagine yourself on Earth, as you are, looking at the moon, Gaia would be able to tell you exactly where a coin was on the moon, which is incredible. That's how precise it is, and how it has to be. Because if you're looking at a star that's really distant and really far away, any sort of tiny nudge in where you think it might be would actually be quite a big error in terms of where you think its position is. And not only that, it's picking up really faint stars too. So astronomers use a kind of a weird system where the bigger the number, the fainter an object is. So Gaia can detect objects that are up to magnitude 20, which is quite faint. So to put that into context, the apparent magnitude of our sun when we look at it is minus 26.7 in the sky. And because of the way the scales work, 20 is much fainter. In more relatable terms, it's picking up stuff that is 500,000 times fainter than your human eyes can see, unless you're bionic and have huge mirrors. Gaia is sending back 40 gigabytes of data every day. It is going to eventually take 490 billion measurements of the positions of stars, because you have to measure them more than once to make sure that you've got it right and you can correct for any errors. Plus, as well as all the positions, it's going to be getting things like spectra, which tells you about the chemical compositions of the stars, and it'll be getting photometry, which tells you about the colours of the stars, and you can infer stuff about the temperature that way. So there is so much more to come. And it's not even stopping at the stars. It's getting data for 1 million galaxies and 500,000 quasars, where a quasar is basically a galaxy with a black hole and there's like this really big bright jet and it's pointing quite in our direction. And as well as that, it's also getting solar system objects. So it'll be looking at the Kuiper belt, which is where Pluto lives, where there are some really faint things there. The only reason we can see Pluto so easily is because it's really bright and reflective. So it really is all very exciting. You can see where loads of the stars are yourself by clicking on some of the links to ESA's websites that I've put below. But the thing is, why do you actually care about the positions of stars? Like, don't we already know where all the stars are? Turns out we don't. So the last time that there was a mission like this was a satellite called Hipparcos, and this launched in 1989, it kept going until 1993, and it got the positions of 100,000 stars. But even that is not enough. As I told you before, 1 billion is only 1% of the total population of stars in the Milky Way. So really we need a lot more stars to get more information about the galaxy. Plus the precision is going to be much better too. Without accurate measurements of the stars' positions in the galaxy, it's much more difficult to find out about the structure of our galaxy. Because we're inside it, we don't actually know what our galaxy looks like. So we can start to do this if we build this map and start figuring it out. The other cool stuff from getting the colours and the chemical compositions of stars give you even more insight. So not just the structure of the Milky Way, which it will give you, telling you where certain types of stars are, but it will tell you more about the history of the Milky Way, more about its formation and any major events that happened in its past. The more detail we have, the more detailed we can make our explanations. So at the moment we have these positions, which are awesome and they're really great, and we also have a little bit of photometry, I think, and a little bit of the proper motions of some of the stars. But in the future we will have this thing called the radial velocity of 2 million stars, and that will give us a 3D map. So not just where everything is, but where it is in 3 dimensions. Plus, as I said, all these chemical compositions and colours of stars, which are super useful for doing loads of cool stuff to do with the Milky Way! Woohoo! One more thing to mention, the big sort of super duper amazing, unique, cool thing about Gaia is that all the data that is ready is publicly available now. so anyone can just pick it up and do science with it, which is really cool. Until next time, keep being curious.